Rough Cut, the Institute on Ecosystems Rough Cut. I'm Bruce Maxwell, MSU Director of the Institute on Ecosystems. And today we're very lucky to have with us Dr. David Titley, who is visiting and has many things here to talk about. We couldn't have a better authority, I think, on climate change than Dr. Titley. So we're really lucky that he happens to pass through Bozeman, and we happen to learn that he's passing through Bozeman to grad. So Dr. Titley is a professor of practice in meteorology and a professor of international affairs at Penn State University. He is the founding director of Penn State Center for Solutions to Weather and Climate Risk. After graduating from Penn State, Titley served as a naval officer for 32 years and rose to rank of Rear Admiral. Dr. Titley's career included duties as commander of the Naval Meteorology and Oceanography Command and oceanographer and navigator of the Navy. While serving in the Pentagon, Dr. Titley initiated and led the U.S. Navy's task force on climate change. So it brings to us a very interesting perspective.
So much to you and really to Montana State for inviting me here. I gave a couple talks at MSU, I guess it was 2 or 3 years ago, really enjoyed it, and it's always a great pleasure to come back out to Bozeman. So what I'm going to do is actually talk very little about the science. I'll talk some about how climate change is seen as a impact to national security. And I'm using a kind of a narrow definition. It's like how the Department of Defense sees it. There's much more to security than just the DoD. But I'm going to talk about how does the military, if you will, look at this issue. And then I'm going to talk about kind of at least where I see some of the politics playing out, both within security, maybe a little bit broader. I mean, tremendous amount happening this week. I got an alert on my phone about 2 minutes ago that said Michael has now made landfall on the Florida Panhandle, strongest storm in over a century and probably a lot longer than that. IPCC, probably just about everybody in this room knows, came out with a special report on the end of this weekend. We'll talk a little bit about that as well. Okay, so with that, and now we'll have time for questions. As I mentioned, Michael went ashore. These are pictures from my house of Katrina. And you will start seeing my forecast, and I'm a recovering meteorologist, so forecaster. My forecast is you will start seeing pictures just like this in about 1 to 2 days when people can actually get into some of the towns. Panama City likely took some very, very strong winds, and we'll see. That's going to look almost like a tornado went through. Huge storm surge. I think the Weather Service is significantly underestimated the likely storm surge to the east of landfall. There could be some places approaching 20 feet of storm surge. It's a very dangerous part of the Gulf of Mexico for storm surge for a variety of reasons. So you're going to see pictures like this and like this. This is Bay St. Louis, but this could be some of the small towns just to the east of Panama City. You will see signs like this. This is how you found this was 2 doors up from me. And really you will see some of these kind of things that are just heartbreaking. So whatever you can do to help the people down there. They're going to be in a world of hurt. The people who rebuild, it will probably take 5 to 10 years, and there will probably be quite a few people who just move away. That's what we kind of see. You'll hear lots of rhetoric and lots of all kind of stuff. That's kind of the reality of how these things are going to play out. So I just added this morning because I realized that as I was talking, the storm was probably making landfall here. Okay. As was mentioned, I ended up in the Navy. Why? Because I needed a way to pay for college. I was out of state, going to Penn State. I don't know how Montana State is for out of state, but Penn State's pretty expensive. And my parents said, congratulations, you got into college. Now figure out how to pay for it. Thought I was going to be in for 4 years. Turned out to be 32 because they didn't throw me out for that long. So that worked out. And as was mentioned, I worked for NOAA for a little while, and now I'm at Penn State. It's a lot of fun. Mike Mann is a colleague of mine. He's about 3 doors down. We collaborate on a lot of things. We actually have a a paper on storm surge that was just accepted. It'll be coming out, well, it'll be published in about a month or so, as soon as we get all the paperwork done. So it's a lot of fun to be working with. And if you want the 7-minute and 42-second version of what I'm going to talk about, type Titley TED, and you can find it there. The interesting thing about TED that I learned, I was telling Bruce this just earlier, is you film these things in front of a live audience. It's about, I don't know, has anybody gone to a TED, actual full-blown, no-kidding TED convention? Yeah, you need to write them a check for $10,000, no kidding. And there's about 1,000 to 1,500 people in the audience, and they're all basically bored, billionaire, libertarian, Silicon Valley types, for a large part. So they look at climate, and they haven't really done much with climate in TED. And the reason is they say, well, you know, when it really finally becomes an issue, there'll be an app for that. There'll be some sort of easy technological fix. That kind of, let's see, we're recording, so I have to use good language. That scared me a lot. I'll put it that way. I would have said some other things, but we've got a tape recorder. That's okay. Oh, okay. You can take it out in editing. Yeah, that's famous last words when the media says, "Oh, we'll take it out in editing." It's like, yeah, this is the first thing. This becomes the lead. Yeah, I know how this works. So, anyways, it's an interesting thing, but I'll talk a little bit about some climate intervention a little bit later here. Okay, when I talk about climate risk, I mean, so I don't know. Has anybody read the entire special report that came out on Sunday from the IPCC? It came in at a svelte 1,252 pages. I added them up. No, I did not read it all. I was happy I made it through the summary for policymakers, and I'm guessing that's probably what about 95% of the people read. And then if you have researchers, if you have grad students or postdocs and you're interested in something specific, you send them to a chapter and dig through and then dig into the references and stuff. That's great for the science community, but for the public, it's like, that's really hard. So I try to do things, I'm a pretty simple person. I found that I can remember 3s, but that's about it. If somebody gives me a list of 6 or 8, I'm lost, but I can do 3s. So I talk about climate risk is really about people, about water, and about change. And if you think about it, you know, why do we care? Well, we care because we're humans, so we're selfish, and it's about us. It really does affect us. It affects a lot of other stuff as well, but it does affect us. And you know, it affects you and me, and it affects our parents, it affects our kids, it will affect our grandkids as well. People in our communities, in our towns, whether they're in the cities or working, whether they're producers working the land. It affects people in the Northwest. It affects people really all throughout this country, and frankly all throughout this world. This is fundamentally a people issue. I would argue that water is one of the integrating principles you can also use on climate. These little 3 blue dots, if you can see them, it's all the salt water, all the fresh water sort of over Tennessee there. And that tiny dot that almost looks like a smudge is the usable fresh water, the one that blue dot over Atlanta. But how that water gets distributed has been relatively stable for several thousand years, and now it's changing. And now we're getting too much and too little, wrong place, wrong time. It's salty where it used to be fresh, wet where it used to be dry, liquid where it used to be solid. And even the chemistry of the ocean is changing itself, which in turn is changing food webs that we don't really understand even when it was stable. And 1 to 2 billion people, that people thing, get their primary source of protein from the ocean. So the water and how it changes, and whether it's Florence, whether it's Harvey, whether it's sea level rise, whether it's been drought in the west, which has exacerbated wildfires, whether it's been flooding in the east and these rain bombs, a lot of the climate risk we're seeing can be tied to water in some way, shape, or form. And then finally, I saw this in a coffee shop. I thought it was kind of cool. If I ever, you know, take up another career as a barista, that's going to be it too. But it's a change piece, you know. I mean, so I live in central Pennsylvania. We're getting towards November. We probably won't see the sun again until March because that's just kind of how it works. Nobody would claim it's ideal climate. I mean, I don't know. Anybody here used to live in either Honolulu or San Diego? Okay. All right. Okay. You guys had ideal climate. That's pretty close to ideal. But the rest of us, I mean, it was pretty darn cold walking down Main Street here in Bozeman last night, I got to tell you. But we've had a stable climate. We've pretty much known what would grow, what wouldn't grow, what critters we had to deal with, about how much water, about when that water would come, whether it was equally distributed or whether there was a rainy and a dry season. And all of that is changing. And it's not that we can't adapt, but there's a whole ton of people that all have to adapt to this. And we've built our infrastructure on this implicit premise of climate stability. It's not like the Egyptians said, hey, I think we're going to have 7,000 years of climate stability. Let's go build pyramids and the rest will all follow. You know, then we'll all end up with iPhones. But we've had that stability. You could build a city on the coast, and you could use that port, and it wasn't that it was all going to flood out, and it wasn't that you were going to find the port by and large, 5 kilometers downstream in a century or two. So we had basic stability, some small changes, but basic stability. And now we're going into a period where the climate is changing pretty much as fast as we've ever seen it change on the Earth. And it's an open question as to how the now, 7+ billion people, we are all going to manage that transition, let alone the ecosystems. But this is a huge change, and if we do this poorly, it will certainly be a big security issue, along with many other kinds of issues. So people, water, change. That's really how I think of it. I know the IPCC writes stuff this big, and it's really hard to figure out sometimes what the 3 big take-home messages. That's kind of my take-home message. Okay, on the sciences, I'm just going to go through this quickly. My guess is everybody in here kind of knows enough or more than enough about the science. And I'm going to go through this not to tell you that 97% of practicing climate scientists understand that the climate is changing and that we're causing it, and therefore you should just take that. But kind of from first principles, why is it? Why are the climate scientists so convinced that, in fact, the climate is changing, and we know why, and it's primarily human-driven? So again, I can only do 3s, so these are the 3s. Do we understand the physics and the theory? This is sort of like, Newton and Einstein, F equals ma and E equals mc squared, all the way down to the fundamental physics. What does the real world say? What do the observations say? And at least in the physical science community, like meteorology and climate science, can you predict it? And a better way to put that is, can you be right for the right reasons? I mean, the stopped clock is right twice a day, but that doesn't, if you guess enough, sure, some of them come up, but can you actually predict whether it's a weather event or a climate event? And it's like, I got this because I understood how the atmosphere is really working. And if you can say yes to all 3, then I argue you have understanding. So spoiler alert, in climate science, for the why the climate is changing, yes, yes, and yes. And we have very high confidence in all 3 legs of these stools. I'm not going to make anyone derive the equation here. That's okay. I do that occasionally in my undergraduate class. But this is just the radiative transfer equation. This really just kind of gets down into the partial differential equations as to how it is that certain gases actually re-radiate the heat. So again, if you're talking to your Thanksgiving's coming up, so that weird brother-in-law is going to show up again, right? Yeah, that guy. And telling him that carbon dioxide is a blanket, that's fine. I mean, unless you're like in some 400 level thermodynamics class, that's good enough. It's a good enough explanation there. So basically, we're re-radiating, certain gases re-radiate at the temperature that the Earth gives off the heat. And again, it's very similar to a blanket. We actually see that the sun itself has not been increasing. If anything, it's tiny little bit of decrease. It's basically flat though. Another kind of smoking gun we see is that the upper atmosphere, where none of us live, like 20 kilometers and higher, is actually colder now. They've got global cooling going on. So, but it's at 20 kilometers and we don't live there. So we're really redistributing the heat. If the sun was adding heat, then everything would be getting warmer. But that's not happening. We're redistributing the heat, and we're keeping it down here, where we all live and where really all of the ecosystems are. And we've known this for a long, long time, right? I mean, I tell people sometimes this is cutting-edge 19th century science. You go back to that guy Fourier, so anybody who had calculus, it's like, yes, it's that Fourier of Fourier series, same guy. Back in the 1820s, he basically figured out that the Earth would be a whole lot colder without an atmosphere. We would be roughly 0 degrees Fahrenheit, minus 17 Celsius. We would be a snowball. None of us would be here right now because we'd be a snowball. The guy in the middle, Tyndall, a Scot, he in London in the 1860s sort of did the TED Talks of the 19th century. So it was like an auditorium like this, but it was those great Victorian things with the really steep stairs and seats. And they had this wonderful sort of Victorian scientific apparatus. And he was the one who kind of figured out that only certain gases really trapped or re-radiated that heat. So he would put in oxygen and nitrogen, of course that's the vast majority of the atmosphere, no change. Put in carbon dioxide, huge change from one to the other. So really Tyndall was one of the guys who really first figured that out. Now by the time you get to Arrhenius, a Swede on the far right, about the turn of the century, 1899, 1900, he actually started doing the first global warming calculations based on the Industrial Revolution. And his basic premise was not bad. He underestimated how much CO2 we were putting in, kind of a common theme for us. But he'd kind of figured out the basics by that point. So, you had a French, a Scot, a Swede. As far as I know, they did not go into a bar. But by 1900, we had kind of figured out a lot of the theory. And the bottom line is that has withstood the test of time. So who here considers himself to be a scientist or a student scientist or going to go into the science field? Most. Okay. How do you get everlasting fame in the science community? Do you confirm the results of thousands of others? Or do you actually find something that no one has found and thousands of others confirm your results? So they will name halls and universities and institutes and peace prizes after you. Oh, that's dynamite guy, never mind. Yeah, it's the latter, right? So I tell people, especially when I talk to people, it's like, oh, you guys are just in it for the money. It's like, have you seen how much paperwork you do for an NSF grant and how little money you get out of it? It's not the money. But if you could figure out something that said, hey, all these guys were wrong and everybody else, and you could prove it, and others independently could prove that you were right and they were wrong, you will be known for centuries. It's the Holy Grail. No one has done that. That's why we think this is like really, 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 really solid science, because no matter how many different ways we look at it, we come back to the same answer. Okay, tons of observations. This is where most people stick in a temperature graph of some sort, and yes, I've got a million temperature graphs, be it of the air temperature or of the ocean. But this is a little more interesting to me because maybe it just hasn't been used quite as much. So Munich Re, if you haven't heard of them, I mean, we all know of like our insurance companies, the Allstates, the State Farms, the Progressives, the Geicos. You may or may not know that those insurance companies actually buy insurance policies. Why? Because if they have a really bad day, like they're having right now on the Florida Panhandle, they're going to go through all their money really fast. So it's like, just like you and I, if we have a bad day with our house fire or a car or whatever, we need help. They need help too. And they go to what they call these reinsurers. So these reinsurers usually have ultimately tens of billions of dollars of underwriting. They got a lot. And they just care about the risk. They really don't care about the politics or anything like that. They care about the risk. So one of the things that Munich Re has been doing really for a long time is just counting the number of disasters. And again, just in the interest of time, I'm not going to go through sort of the distinctions between meteorological and hydrological, fancy word for water, climatological, but sort of those colors above the red, you can kind of see year-to-year variations, of course, but on average, and this is over the globe, I would say, they're increasing. Those red ones, what does that trend line look like on the red ones? Probably flat. I mean, and it turns out it is flat, certainly to 95%, but even less than that. It's or at least higher than that. It's a flat line. That tells me, that gives me actual confidence. Those are like tsunamis and earthquakes and volcanoes and things that are not climate related. So that tells me that Munich Re is probably not conflating with either population, which we know has gone up a lot, or wealth, or number of people moving to the coastline, or all these things that you sometimes see people say, oh, well, the reason hurricanes are worse, it's not that the hurricanes are worse, it's that there's more people. Well, yes, there are more people, but we're actually also seeing more weather and climate related events. So that's just one set of observations. And again, we could do a whole week, we could do a whole month, you could do a 3-credit course on observations. But I like you guys, so I won't do it. Predictions. So there was this guy, Jim Hansen, the climate guy, not the Muppets guy. And back in 1979, and I believe it was in Nature, it was Nature or Science, I think it was in Nature, he published those black lines. It was one of the earlier publications Hansen did that started in about 1979 or 1980, and it was that black line, and by about 2000 you had to make some assumptions on how much greenhouse gas we were putting into the atmosphere. And somebody got the bright idea of, hey, that Hansen guy published it. And, you know, we could just go across to the library here and find the publications right there. How did he do? And it turns out that big, thick magenta line is sort of the 5-year average of the individual temperature anomalies. So, you know, was he exactly right? No, he was actually conservative, if you will. And this is kind of a trend that we've seen. If, you know, there's certainly have been projections that have been too aggressive. But on the average, if you look at where the climate science has been, we've probably been shooting behind the rabbit a little bit. Certainly in the Arctic, certainly with Arctic ice, to some degree with temperature. I would say also with extreme precipitation events, we've been shooting behind the rabbit. So when you think, oh my God, these climate guys, they're gloom and doom and alarmism, we're probably not quite as far forward as we need to be. Having said that, I would argue that Hansen's model was very useful. You know, you've probably all heard the George Box saying all models are wrong, but some are useful. I would say that was very useful because he basically said, hey, we're going to get on this escalator and it's going to go up and it's not going to go back down, and that's what's happened. So again, I hope this sort of very, very brief tour of theory, observations, and we can predict this stuff is why the scientists are so convinced that these are happening. And this is really gets frustrated when you hear either in the media or a very few people saying, well, geez, no, we just don't know anything, or this is false. And it sort of creates, in a lot of places, this impression that, well, geez, it's a he said, she said. There's some people who think this is happening, a bunch don't. That's simply not the case. Now, what to do with it or about it, that's where the policy debate should be. Is it happening? That's honestly not where the debate should be. Okay, I'm just going to talk a little bit about attribution. So I probably had this slide 6 or 7 years ago. And you know, you get these big events, whether it's storms or snowstorms or flooding. That's Katrina, I think, on the left. You know, droughts, and we used to say that we could not actually attribute any specific weather event, but I would talk about this in terms of climate, kind of, you know, changing the cards in a card deck. Imagine, you know, I can't use this example in Utah, but I probably can in Montana. If you were playing poker, I saw some place that said it had poker on Main Street, so I guess this is okay. You know, if you had, you know, full house aces high, you think that's a pretty good card deck. But if your card deck starts looking like that, don't go to Vegas with that card deck. You know, you're going to get a few more of those. You're going to get, that hand is going to show up more than you would think. And that's how we used to talk about attribution. I had the honor of chairing a National Academy of Science committee on attributing specific weather events to climate change. And this is kind of the iconic, if you will, graphic that came out of that study from 2016, 2 years ago. And really what we showed was we had different levels of ability to attribute, again, a specific event to a change in climate. And we pleaded that people should not ask, was event X caused by climate change? It's what we would call an ill-posed question. But was it made more likely or less likely, more severe, less severe, weaker? Those are questions that science can answer. We do these attribution studies, and if you're interested, you can read the report. We kind of came up with recommended best practices. You got to watch out for things like sample bias. We all tend to do the interesting things in cool places, but we may be biasing our samples, so we just ask, that we look at that. It's a combination of, again, do you have observations? Can you model this? How do you do that world without climate change? And you have to be a little careful. At one point, this sort of becomes almost this tautology. Since the climate has changed, you can argue that every weather event has changed because it's happening inside of a different set of boundary conditions. That's true. I'm not sure it's useful, though. I think when people ask, are these things changing, they mean changed relative to what they remember 20, 30, 40 years ago, and how has it changed? And for heat and cold and droughts and extreme rain, we're pretty good. Tropical cyclones, so-so. That bubble, even in 2 years, has probably moved somewhere to the upper right from where it was. Wildfires also moving to the upper level right. Severe convective storms, fancy words for like tornadoes and really severe thunderstorms, really very hard right now to attribute a specific, let's say, tornado outbreak to climate. We don't see that yet. Doesn't mean it's not happening, but we don't see that yet. And again, you can Google this report if you're interested in it. Okay, I'm going to kind of shift here to more on the security risks and then to kind of where we are. So again, very quickly, I can only do threes. That's kind of the theme, right? I can only do threes. Why, climate and security risk, and again, sort of how the military would view this. Are we changing the operating environment? Are we changing where we send our soldiers, sailors, airmen, and Marines? I mean, the American way of war is we don't want to fight the home game. We fight the away game, wherever away is. But we want a home field advantage when we do it. So we better understand the terrain, and we better understand the weather and the climate and the environment. Because otherwise we're going to have the wrong training and the wrong type of equipment, and our 18, 19, 20, 21-year-old sons and daughters are the ones who pay that price. So the Arctic, you could argue, is the poster child for a changing operating environment, but there are other places too. Impacts to security infrastructure. That's a fancy way of saying bases and training ranges. The obvious places, of course, are along the coast with sea level rise or a combination of sea level rise and storm surge, but it's not just there. Black flag days, basically days of very high heat and humidity. Wildfires. Wildfires do, I know it's a big deal out here for a lot of reasons, but for the training ranges and for the bases out in the west, and even in Alaska, especially in Alaska, the fires have a huge impact. Not so much that they're expecting the Army troops to put out the fire, but it really impacts sort of that high-end training that you can do. And then this making bad situations worse, this is sort of the geopolitical impacts of if you have a drought which leads to an agriculture crisis, and you have poor governance, and your government either does not take care of you or just compounds a situation and makes it worse, you can take a bad situation and make it catastrophic. And Syria is kind of a poster child for that. Anybody here remember the old BASF commercial? We don't make things, we make things better. Some of you do. Climate is the opposite. We don't make things, we make things worse. Okay, just a couple things in the Arctic. This is actually not the minimum. These are the maximum. This is March of 1990 and March of 2016. Same type of calibration on the sensors. It's microwave imagery, so it can see through clouds and dark and stuff like that. The white is the multi-year, the hard sea ice. Anybody work in the Arctic or has done research up in the Arctic? Okay, so you all know that 20, 25 years ago, a good 50, 60+% of the sea ice was actually what we would call multi-year ice. Very hard, relatively stable, many meters thick, several meters thick, and it was kind of permanent. It was semi-permanent. Fast forward to now, we're down to, depends on the year, 10 to 12, 10 to 13, 10 to 14% of that multi-year ice. Most of the ice is 1 to maybe 3 years old, much less stable, much more movable. We've actually had some researchers lose their lives out on this stuff. They thought it was stable and it wasn't, and the ice just collapsed. We've had others, both the Russians and the Americans, have had to evacuate their ice stations or their research stations very quickly because the stuff is moving around. So tremendous change. So again, not a ton of people pay attention to the Arctic, but this is a place in which people are not waiting for climate change. It has happened. Those are profound changes basically in our lifetime. And those changes are continuing. It changes trade routes. The blue is the Northwest Passage. Honestly, the Northwest Passage is kind of like US Route 66. It's iconic and people love to write about it and talk about it, but we don't have US Route 66 anymore. And for a variety of technical reasons like the draft, and it's a very challenging sea and anchor detail, and whatever ice is left, this is about the last place it's going to be in the Arctic is around that Northwest Passage. I don't see in the foreseeable future the Northwest Passage becoming a major shipping route. The two that are more interesting are the red line, we call it the Northern Sea Route, mostly along the top of Russia. Russia has 50% of the Arctic coastline. The Russians have been working hard to monetize that route. They have roughly 3 dozen plus icebreakers to keep it open. But we're starting to see, we saw this February of 2018, a liquid natural gas tanker that's built to run in the Arctic, make the transit from Scandinavia to China along that red line in February, last I checked that was winter, with no icebreakers. Why? Because it's thin ice. So these things are changing. The container vessels, the container vessels are sort of the world's warehouses now. Everything's just in time. I can't tell you how many times I've been on a panel on the Arctic with a very senior person from Maersk Shipping who basically said, hey, look, container vessels, we ain't coming to the Arctic, not gonna happen. Well, guess what Maersk ran last month? Container vessel. From China, actually, from Asia to Russia, to Eastern Russia. It contained frozen fish. Maybe that was their risk mitigation strategy. I thought that was interesting. It was frozen fish. It was certainly not their biggest ship by any means, but they were kind of looking at, hey, maybe we are going to be opening up container routes. And that green line, to me, is a really interesting one because that's open water and you don't need Russian permission or icebreakers or anything else. It's not open yet, but I think that over-the-top or transpolar route, probably in 15 to 20 years. And you see the Chinese very, very interested. They're interested in ports in Iceland and Greenland at the terminus of these. And you can see that if it's not the US, somebody is going to monetize that route. And it's going to happen for anybody who's a student here. It'll happen when you're early to mid-career, in whatever career you decide to go into. The Chinese are really paying attention along with the Russians. They sort of call it this polar Silk Road. For anybody who studies China, you probably know about their Belt and Road Initiative, a multi-billion, perhaps trillion-dollar infrastructure initiative. This is the northern link to the Belt and Road Initiative, and it really goes right across Russia. So if you're Russia's always thought the West and the US was trying to encircle them. And I tell my Russian buddies, you're encircled all right, but it ain't by us. You look at the Belt and Road along the south border, you look at what the Chinese are working in Europe, and then you look at the northern one, it's like, yeah, you're circled. So look at Mr. Putin and Mr. Xi in the top left. Putin is smart enough to know he's being kind of had there. One person is smiling and one is not. I think there's a reason. Okay, this to me is kind of a place where science and political science and international relations really meet up here. So yes, the science is going to help tell us how that ice is going to evolve, both the sea ice, also the land ice, the Greenland ice sheets, along with the Antarctic. Incredibly important to understand the rate of sea level rise in the upcoming decades. But how the geopolitics play out, this is not the climate scientist domain, but this is a great interdisciplinary opportunity between the political science, international relations, and the physical scientists. This is a capture in the top right from a hearing I testified at back in July, I think it was, on maritime transportation, and it was very interesting to me that the majority and minority members of the committee sounded identical. So I'm expecting to go, and it's sort of a climate thing, and it's like, okay, we're going to do this again. Both members of Congress on the Democrat and Republican side were basically saying, hey, this administration, you guys are ignoring what's going on. We've been ignoring it for a long time, actually. What's going to happen? Interesting quote from Secretary Mattis on the left. I've seen the words, I have yet to see the actions, and in fact some of the actions I've seen from the US Navy, very frankly, show that maybe we're trying to pull back on what we have already been doing. I think the jury is still out, and I think that debate is being had within the Pentagon, but I can tell you, at least in the House of Representatives, they really are pretty unhappy with where the US is, and they kind of want to put a size 14 boot up a certain part of the anatomy to get things going. We'll see if that happens. Infrastructure, this is Norfolk. This is usually what we think about. This was Hurricane Isabel. So this is how it works in the Navy, especially in Norfolk. Norfolk's pretty vulnerable, and it turns out that ships are much more vulnerable when they're tied to a pier. They can, if you start getting 60, 70 knots of wind, they're either going to rip away from the pier or they're going to beat the pier into shreds. So you send them out to sea, and then you can use them for whatever you need. So, but think about how this works sort of on a family basis, and my wife was here, she would agree with this. You kiss your spouse and say, hi, enjoy the hurricane. I'm sure it'll be great. I'm going to sea. I'll be back in 5 or 6 days. Drive down to the pier, park your car, leave. Well, my guess is there were a bunch of unhappy sailors when they came back because they weren't thinking of the storm surge. And it's like, well, of course there's storm surge. Well, what's happening in Norfolk is between sea level rise and there's some local effects, so Norfolk's actually sinking. You're changing the effective sea level rate in Norfolk very rapidly. So, even like 10 years ago, hey, it was a category 2 storm, and I didn't really have any problems. And now you get this sort of thing. So what we're seeing that you don't even have to make assumptions on whether hurricanes or typhoons are getting stronger. The fact that the storm surge is coming in on an ever higher sea level base impacts these surges and the damage that they cause. Syria, really the takeaway for climate is I've testified before Congress on this, and there are sort of two extremes. One extreme, sort of exemplified by Senator Sanders, is climate change caused Syria. Senator Cruz said climate change had absolutely nothing to do with Syria. With all due respect, I would say that neither of those viewpoints are correct. The truth is somewhere in the middle, and climate change was one of the links in a chain of events that ended up in catastrophe. So climate certainly, and we can do the attribution studies, and they have been done, certainly climate intensified and exacerbated the drought a decade ago in that part of the world. But this goes all the way back to the early 70s. When Assad took power, he decided that he wanted to be self-sufficient in grains, like wheat and barley. Now you would hope his advisors would have said, hey boss, we live in Syria, it's Eastern Med, kind of a desert, maybe not the smartest idea you've ever had. But I think what they said is, boss, you are a smart, powerful, and handsome man, and we'll get right on it. Now, that would never happen in this country, of course. But, and they did. By the 90s, they were self-sufficient. But they did this at a cost of their aquifers and fresh water. Non-climate events also played a big role, like the Iraq War. 1 million Iraqi refugees pour into the Syrian cities. It's Assad. Do you think he takes care of the refugees? Do you think he cares? No. In fact, he does, if anything, he exacerbates and foments the tensions and the ethnic divisions and the religious divisions. So you're sort of pressurizing, think of that pressure cooker, and you're pressurizing it. Then the farmers in this drought really just have nothing. And it's not like it's a bad crop, it's like no crop. So they, 750,000 farmers, Syrian farmers, internally displaced people, on top of those million Iraqi refugees. And now you just have, again, and it's Assad, he's not taking care of anybody. And this is what you have, and you just go into chaos, because now you have this breeding ground for extremist groups. You have many desperate people who have nothing. No food, no water, no security. How do you take care of your family? How do you take care of yourself? And it becomes this breeding ground, and now we have a catastrophe. We have a human catastrophe, we've had a migration catastrophe, we have a geopolitical catastrophe. The Russians are back in Syria for a generation. They were out. We had them out, and now they're back, and they're probably going to be there for a long time. It's bad on every level, and there are no good choices at this point. There are only less bad and really bad choices. And climate was one of the links in that chain. I guess that's what I would say. It's one of the links in that chain. Okay, what to do? Well, first, admit you have a problem. Secretary Mattis has, in fact, in his, occasionally, he has talked about this. He's certainly not a believer of this as a hoax or this doesn't matter, but put yourself in his shoes for a nanosecond and imagine the sort of issues you're dealing with and the boss you're dealing with. I understand why this is not his top issue. It has never been any Secretary of Defense's top issue, and it certainly is not going to be his, and I understand why that is. But if you look, you can see on the left, this is an intelligence study that came out in September of 2016. It comes from the intelligence community because of a really catchy title, Implications of U.S. National Security of Anticipated Climate Change. You can still find it on the web, by the way. Again, written by our senior intelligence professionals for the National Intelligence Council. I've got it up there again. There are plenty of, at least on paper, ways to adapt and manage this problem, most of which were signed in 2016. The presidential memorandum, unfortunately, has been rescinded or been canceled by the current administration. This Department of Defense directive you can still find on the web. And I tell the DoD, if you just did what your own directive says you're going to do, you'd actually be in really good shape. They put this out in the last year of the Obama administration. That administration then did nothing with it except put it on the shelf and say we signed it. This administration, we thought they were going to cancel it. They did not. That's good for bureaucratic reasons because it takes about 2 years to staff these things. The good thing is, if you want to say that the glass is a quarter full, is this thing is on the shelf, and if you have to sort of resurrect it, it's there. You don't have to start from scratch, which is just this massive bureaucratic issue. Nobody's doing anything with it, and that's too bad. If you can remember my 3 things of people, water, and change, and if you can remember that leadership counts, I'd be really happy. These are some gentlemen that have really made a difference. The guy on the top right, that's Admiral Gary Roughead. He was the head of the Navy and basically hired me to start Navy's Task Force on Climate Change. Had he not done that, it's not like a 1 or 2 star admiral is just going to start this and get the Navy to pay attention. I had for a few months what I call a 4-star hunting license. So what this means is, I'm a relatively junior admiral, and in the Pentagon, 1 and 2 star admirals and generals, they're a dime a dozen. You can buy them at Walmart. It's there's a ton of them. But you say, hey, look, and if I would run into a 3-star or 4-star, we really didn't, this climate thing, I'm not going to do it. It's okay, sir, that's fine. What would you like me to tell the boss when I go see him about this issue next month? Oh, well, it's sort of like somebody who has a direct line to the university president. Sort of. That's academia, so it doesn't really work even then. But, it's oh, geez, this will be annoying, so I guess I better do something. The Pentagon, if nothing else, is a hierarchical institution. So what that means is, if your boss is interested, you are fascinated. The converse is also true. If you figure out your boss is not interested, this falls off your to-do list very, very fast, because just like everybody else, you know, they got a to-do list of 50 and you might be able to do 6 of them. So you figure out what your boss is interested in. Admiral Locklear, commander of all the Pacific, back in 5 years ago, basically said it when he was asked what his biggest long-term security threat was. He talked about climate change. Now, this is the admiral who was responsible for DoD forces in readiness for China, North Korea, you know, Japan, Philippines, South China Sea. He had a lot on his plate, and he said climate change. That remark got him an all-expenses-paid trip to testify before the U.S. House of Representatives. And in Admiral Locklear's very suave and debonair 4-star manner, he basically told the members of Congress, did I stutter? Did you not hear me? He said it very politely, as he should, very respectfully, but he stuck to his guns. That gentleman on the left, anyone know who that is? It's a Rhode Island congressman. It's like, well, he doesn't look like some 4-star. He's not. He's a Rhode Island congressman, Jim Langevin. And he introduced in the House of Representatives, he's on the Armed Services Committee, so they get to write the defense bill in the House, basically an amendment that said, hey, this climate change is kind of a big deal, and the Department of Defense should really be paying attention, and tell us what you're doing with your bases. Tell me your highest priority bases. Now, this is the same House of Representatives that a year before passed a resolution that said there is no such thing as climate change. It has nothing to do with national security, and for God's sakes, don't spend any money on it. Now, fortunately, that amendment did not make it into the final bill, but that was where the House was. So Langevin comes up with something that's like 175 degrees opposite from that. It gets through committee. Liz Cheney, Republican from just down the street in Wyoming, is so pissed off, she basically demands an on-the-record vote in the House. And it turns out that I think it was over 3 dozen Republicans either voted for Langevin's amendment or realized at the exact moment of that vote that their Starbucks coffee was cold and they needed to abstain so they could go and refill it. And they weren't there. And the amendment passed. It passed the House. And it was basically accepted by the Senate that had somewhat similar language, and it was signed by President Trump. So President Trump, he of the climate change is a hoax tweet, has also signed a bill that said climate change is a significant threat to U.S. national security, and the Department of Defense needs to pay attention and do stuff. So go wrap your heads around that. But this happened, yes, there were some behind-the-scenes things and some different people helped with some of the language, but Langevin drove it, and his staff really drove it, and his staff worked hard on some of the lobbying efforts. And to me, that was actual leadership. So leadership really counts on these things. I'll just leave you with a couple slides, and we'll open this up for questions here. It's, to me, is interesting that this intelligence community, and again, you can Google this. It's out on the unclassified, you know, everybody gets it web, Worldwide Threat Assessment, signed by Dan Coates, President Trump's Director of National Intelligence, 2018. Go to page 16 and 17, and you'll see these words. I hope you can read them, but it talks about extreme weather events, and it talks about price shocks, and it talks about climate change and tipping points. It actually talks about some things that the Obama administration never did. It talks about accelerating biodiversity and species loss. Words I never saw actually out of the last administration in an intelligence assessment. Now, how does this feed in? Right now, not very well. It's sort of like you got all these gears spinning, but they're not really together. But there are components, I'll call it the professional, non-political components of the security writ large apparatus, really through 3 administrations now have seen an accelerating risk to these. Does that help in the very near term? I'm not sure. But it is good to remember in the longer term, and if nothing else, this is a longer term game. Okay, I'm going to just keep going, and these are some of the things I've talked about there. Still surprises. You know, that guy on the lower right, Niels Bohr, famously said that predictions are tough, especially about the future. And that goes not only for some of the physics, but also especially for the politics. I circled the little cartoon graphic on supposed to be geoengineering or climate intervention. I was talking with Bruce just before we started here, and to me this is one of the great dangers. I was on a National Academy committee about 3 years ago. We looked at this climate intervention, and basically you can quite effectively cool the earth by spraying aerosols, or tiny, tiny little particles, 40, 50, 60, 70,000 feet up into the atmosphere, kind of simulating a volcano, but continuous. That will cool the earth. It'll probably do a bunch of other things to precipitation that we honestly don't really understand very well. Who sets the thermostat? What happens if you stop? Oh, by the way, all the warning comes back. Does nothing to stop the acidification of the ocean, but it can sort of look like we have a technological fix. There's an app for that. And I think that is going to be an increasing risk. And oh, by the way, it's not really that expensive. It's like billions of dollars, which means most countries could afford it. So this isn't one of these things in which, well, in the US we would never do that, so therefore it's not going to happen. We could wake up one day and find somebody's doing this. There was a huge report, as I think probably most of you know, the IPCC put out just this past weekend that said, hey, all that stuff about 2 degrees, we were kidding. We really mean 1.5. And you can read their summary for policymakers. I, by happenstance, wrote an article for something called The Conversation. It's gray literature. This is, but some of you might see this. It's written by academics, but it is more in a journalistic style. It is not peer-reviewed. I mean, it's the editors fact-check it and stuff, but it's more like a journalism thing than let's say, a peer-reviewed piece. But I wrote this part about sort of the history of 2 degrees, which I found fascinating because I didn't know it before. So William Nordhaus, and now I have to say Nobel Prize-winning William Nordhaus, really came up with this in the mid-70s. It was almost a throwaway. And he spent most of the article where he came up with it apologizing for this. He's like, this is bad, I really shouldn't talk about it. And of course it becomes a de facto standard. I think it was a Swedish Environmental Institute looked at this in the early 90s, and they said actually 1 degree is where we should be. Oh, by the way, we're already there. But since we'll never stop at 1, we'll agree with the 2. And we kind of had the 2. Of course, Paris 1.5 started to become in vogue. And now there's a big push for 1.5. But if you look at, I pulled this actually out of the IPCC, the summary for policymakers. And again, you can argue or debate exactly. I mean, the IPCC has rather defined meanings for all of these terms. But you can kind of look at the colors. The vertical dashed lines are mine, just so you can kind of see where 1.5 is versus 2, and you can qualitatively say, is it more or not? We're coming down a steep hill, and we probably should come down at no more than 20 miles an hour. And you could argue that maybe 2 degrees is 30 miles an hour. Business as usual is 70 miles an hour. Don't do that. That's the coal truck at the end of the 30,000 pounds of bananas, all that kind of stuff. But there's nothing particularly magical about these. 1 is less bad than 1.5. 1.5 is certainly less bad than 2. 2 is less bad than 2.5, which is less bad than 3, and so on. More and more and more people will be forced to migrate because they're going to move low-lying places. Crops will be increasingly affected. The coral reefs already look like they're being very affected. The Arctic will certainly melt out, and probably once you get close to 2, you really start larger scale sea level rise. So yes, 1.5 would be great. Are we going to do that? That's a politics question. That's a political question, and I'm not that optimistic. I wish I could be. But we've kind of blown off all the warnings about 2. We really have. So by telling people, okay, now you have a decade to basically very significantly decarbonize, 10 to 15 years, we'll see. The part is to some degree, this is like market psychology. You can never call the top or call the bottom of a stock market, and it's psychology as much as earnings statements and all this. What is going to be the series of events that really changes us from this very fractious kind of shouting at each other. It's not even a debate, it's shouting at each other. And to a kind of a holy you-know-what moment in which we need to be focused as a country and do things. I mean, technologically, we can certainly make a huge dent. I'm still not sure we can get to 1.5, but we can do a lot, which we are not doing. Will we? That's honestly not a physical science question. And if it happens, I think it's going to happen a lot from the bottom up, and we'll see. Okay, I showed that. My llama. I don't really have time for the llama, but my llama stands for Learn, Local Action, Monitor, and Advocacy. When I talk about advocacy, whenever, I would just ask that whenever you actually have an opportunity to talk to a politician at any level, just ask them, ma'am or sir, what are you doing to stabilize the climate? So it's not a yes or no question. It's, dating 101, don't ask yes or no questions. It's, you might get a good answer, you might not. But it does register. These guys and gals really do know what they care what their constituents think. And as long as they perceive, for the most part rightly so, that even if people care, it's sort of like the Platte River, but nobody cares that much, then this is an issue which then becomes very susceptible to special interest and money and inertia and all that kind of stuff. So things can change. We saw gay rights change. Not a perfect analogy. My climate friends say yes, but they didn't have Exxon arguing against them. They only had the Catholic Church arguing against them. They had some pretty powerful foes. And they were able to change. And when things change, you watch the politicians of both parties running to catch up with the public. They weren't walking, they were running. How do we get there? I think it happens when the public actually cares. What is it going to take to make that happen? I don't know. I don't know if it's going to be a series of discrete events or more chronic event. At some point we will. The only issue is like in the Navy, there's a saying, the two things that are of no use when you're in naval aviation flying are altitude above you and runway behind you. Think of that the next time you're taking off out of Bozeman. We're putting a lot of runway behind us right now, and this is where we're going to get into these, again, really a continuum, but a continuum of ever more, sort of, used to be a 2x4 hitting you, and now it's a 4x6, and pretty soon it's going to be an 8x10 hitting us. And that's kind of the issue. So I'll leave you with, Admiral Nimitz here, probably not known as the world's biggest tree hugger. He did win World War II in the Pacific for us, though. And he talked about, taking precautions. And if you are begrudging, then you're really putting yourself and many others at risk. When we get focused, we do amazing things. We're not focused yet. This was Apollo 13. Probably looking around here, a lot of us probably remember that. I was a teenager. As I read more about it, I realized that by all rights, those astronauts should have been dead. They really should have been dead. They should still be in space. We didn't let that happen. We do amazing things on scales big and small when our country gets focused. We're not there yet, but if we do, we can be leadership to the world. But we've got to decide that's what we want to do. Let me stop there, and I'm happy to take any questions. Thank you very much.